Hello everyone, welcome to this session on Kubernetes. Today in this session we're going to discuss why do we need Kubernetes exactly, and then move on to discuss what is Kubernetes. After that I'm going to show you guys some of the prominent features of Kubernetes which makes it stand out from the crowd of all the container orchestration tools, and then move on to discuss how Kubernetes actually works. After that, I'm going to show you guys the architecture of Kubernetes, which will give us more clarity on how Kubernetes works. And finally, I'll show you guys how you can deploy an application on the Kubernetes infrastructure. Alright, so guys, this is the agenda for this session. Let's move on and talk about the first topic, which is why do we need Kubernetes? Why do we need Kubernetes? So to understand this topic, let's go ahead and understand how our applications were designed before, right? So this is a sample monolithic application, guys. And this is exactly how our applications used to be coded in the past, right? A monolithic application is nothing but where all the features of the application are consolidated into one code base, right? For example, let's take this sample application to be Uber. Right? So you have features like location services, then you have customer service, notifications, mail, payments, and passenger management. Right? All of this is part of one application that you have in Uber, right? But now when you click on notifications in your Uber app, what your application basically does is it contacts the server, and basically you get the notification from the server to your application. So your application is basically reflecting whatever it is getting from the server, right? Now, earlier, all these features used to be on one server, right? For example, if my application has to reach or stream notifications, it will reach out to the same server, and if I have to call the customer support, that API query will also go to the same server. Right now, this might seem okay to you, but this caused problems. Reason being, first of all, this is all in one code base, right? So if I have to do any update to any part of this application, for example, if I have to make changes in passenger management, the way we work with passenger management, I want to change something in that code, I want to update something, right? So for that, I'll have to work in the same code base where my mail is, where my notifications is, where my customer service is, and chances are highly likely that some of these functions may stop working or may malfunction based on the changes that I'm doing in my passenger management, right? So there were a lot of dependency between all the features of this application, reason being it's in one code base. Right? They're not interacting using JSONs, they're not interacting using some other communication, they're interacting within the code, right? And this caused a lot of dependencies. So say, for example, tomorrow my passenger management code fails. So that would lead to, all the features will lead to basically failing, reason being all of them are dependent on each other, right? And this was solved by using microservices. Now, what was microservices? In microservices, we basically decided that all the features should have different code base and should be deployed separately. Now, my customer service is deployed separately. It's in a separate code base. My notifications have been deployed separately. It's in a separate code base, and all of them, they interact using JSONs, right? So if they have to communicate with each other, they'll have to send each other some files or encoded message which the other service will decrypt, and then it will try to read it, and any response which has generated it is again sent to the other service using that same mode of communication, right? So now there were no function calls between these services. It was only API calls that is using JSON that these services were interacting with each other, right? But the problem is now how to deploy these services. Where will I deploy these services? One way is that, say, my customer service module I deploy on one computer, my notifications would be on the other server, my mail service would be on some other server, and similarly, if there are 5 features that are listed over here, there will be 5 different servers which will be serving each services request. It sounds cool, it sounds very distributed also, but when it comes to scaling, it becomes a problem. Reason being that my customer service, the customer service module might not require that much of power that is there in one server, right? But still, my customer service module is occupying the whole server, and I cannot deploy anything over there. So downscaling it became a problem, right? Upscaling is no issue. You can also upscale it, but upscaling would also cause the same problem. That is, say, your server is able to handle 10 replicas of your customer service uh, module, or say, let's your customer service module is being bombarded with requests, and it peaks your CPU to say around 85 to 90% of its usage. Now what will you do? If you have deployed this application on some cloud, your cloud will basically deploy one more server which will have exactly the same service, and now the request will be divided between the two servers, right? But again, the problem is that on the second server, because just the customer service your module is running, it might not be able to utilize the full server, right? It will always be underutilized. So this was a problem that we had to solve, and we solved it using Docker. Now, how did we solve it using Docker? Now, Docker gives you a separate environment, right? So we deployed services on different servers because we wanted them to be totally independent of each other. They should not have any dependency on the other features environment, right? So what we did, we all Dockerized these services, and now all these services could exist on a single computer, right? But at the same time feel that as if they are on different computers. So your application in that case will only be down when your computer or your server as a whole fails, right? Still your applications are independent of each other. For example, your customer service could be running in a Red Hat Docker container, your payments could be running inside a ZS Docker container, your mail could be running inside an Ubuntu Docker container. They all could be different, and they all could be running on the same system. So this solved the problem of underutilization or scaling, right? So upscaling is also okay. So if I feel that passenger management is being overutilized and it's causing a spike in my CPU, what I can do is I can probably deploy one more instance of passenger management, or one more container of passenger management, and the request will then be routed between the two. Also, if my passenger management is not working properly, what I can do is I can shut down passenger management, I can deploy one more container on it, and this will not affect the other application or the other features of your application, right? So with microservices, what you get is zero downtime, right? You get a chance to update your application without causing a problem to the other services, and many more, right? So when we got a Dockerized kind of a scenario, we were like, okay, so things seems to be okay now. But now again, the problem was that how do we monitor these containers, right? So if there are like 300 or 400 containers running, how do I assess which container is running fine? What is the health of a container? Say a container goes down, how do I automatically deploy one more container on it? So this orchestration of containers was a problem, and this is where Kubernetes came to our help, right? Now there are many container orchestration tools, and all of them perform differently based on the kind of features they have. Kubernetes has the most number of features which are essential for basically doing container orchestration. Natively, Docker also gives you Docker Swarm, which you can use to do container orchestration. But personally, I feel Kubernetes has way much more features than Docker Swarm, and that is the reason we're discussing Kubernetes today, right? And most of the industries today are also using Kubernetes for the same reason, that it gives you a lot of flexibility in terms of what you can do with your application. So because your containers were in large number and you had to do monitoring, we came up with Kubernetes. So if Kubernetes was not there, what were the problems? Let's discuss that. So each service, which that is the each instance of a feature which is running, it became difficult to monitor it, right? Scaling a particular feature also based on load was not possible. Reason being that you could not automatically monitor it. You had to keep someone monitoring your usage of the containers, and if they feel that your container is being overutilized, or your container has died because of some reason, then in only in that case it was manually updated, that let's launch a new container and let's scale down the other container, or let's delete the other container. So because of this, like I said, there was too much manual intervention which was required from the programmer's end. Also, if you felt like I told you that all of this existed on one server, right? So the only way that your application will be down is when your server is down. So we had to mitigate this. So if we deployed containers on multiple servers, now to manage or to know how many containers are running for a particular service on multiple nodes also became a problem, right? And there was no way we could solve it without a tool which could basically orchestrate the containers for us. And this is exactly where Kubernetes saves us. So what is Kubernetes? So I think we have discussed most of it, but Kubernetes is nothing but a container orchestration tool which is used by our application to basically monitor or orchestrate multiple containers. The kind of features that it gives us is monitoring. It helps us monitoring containers. It helps us scaling containers. It also helps us restarting containers if any of them fails. And this all happens automatically. There is no manual intervention required for this, right? And this is what Kubernetes is all about. Now, what are the features of Kubernetes? So we discussed some of them, like it could monitor it, it could scale it, but let's just come more about it in detail, right? So the features of Kubernetes include the first one being that managing multiple containers as one entity, right? So if you have 400 containers which are running, which probably have 5 features running on it, you will only see those 5 features. You will not see how many containers are running behind it, right? I mean, you don't have to worry about the number of containers running behind it because Kubernetes automatically it takes care of the health monitoring and scaling up of your containers, right? You only have to worry about what kind of services you want to launch. Is if there is a new feature that you have to include in your application, all you have to do is launch a new deployment which will basically have those feature and the number of containers that you want for that to be supported with. You just have to specify the number and Kubernetes will automatically take care how it deploys it in the backend, right? So managing multiple containers as one single entity became very simple for us after Kubernetes. Resource usage monitoring was also solved by Kubernetes. So with Kubernetes, what you can do is for every container which is running, you can basically define how much of your computer resources it is going to utilize, right? And the moment the container utilizes more resources, what Kubernetes does is it deploys a new container, right? And that is how it basically does resource usage monitoring. Then we have networking. So networking is a fantastic feature in Kubernetes wherein all the containers which are deployed on the Kubernetes cluster basically can interact with each other as if they were on one system. But they could be on 100 nodes or 200 nodes or 300 nodes, but still they can interact with each other irrespective of the fact that where they exist on the cluster. So that is also a fantastic feature. Then we have something called as rolling update. So if you want to update your application, you have the option of doing a blue-green deployment using the rolling update feature. Then we have something called as load balancing, right? So all your containers, if there are multiple replicas of the containers which are running inside your cluster, you can automatically load balance among these containers based on the request, right? That is also a feature which is there in Kubernetes. You have health checks, right? So health checks basically means if your container is not running as it was supposed to run, or say it is down, or the service itself is down, Kubernetes will take care to redeploy the container so that your service is always up, right? So you will never notice any downtime when your container is running inside Kubernetes until and unless there's some problem in the code, right? If your code runs fine, everything is going to run fine in Kubernetes. Moving forward, now let's discuss about how Kubernetes actually works, right? So Kubernetes, like I said, it's basically a cluster. So you have a master and then you have several nodes inside the master, right? The job of the master is basically to schedule containers on the nodes which are under it, right? Monitor the nodes, monitor the containers which are running inside each node, and also keep a track of the logs of what operations are being performed on each container, right? So basically the master plays an important role here of monitoring everything, of scheduling everything, while the workers or the nodes do the job of processing with whatever is required in your application. If it's processing, if it's sending API calls, it could be anything, and that is handled by the nodes. But Kubernetes is running on both the master and the node, right? And basically it's the same software running everywhere and they can interact with each other as if they were one whole system. right? It is also very easy to add more nodes to the cluster, to an existing cluster. It can be done in a jiffy. All you have to do is just, there is one command that the master gives you once when it's initialized. Just save that command, and whenever you want to attach a new node to the cluster, all you have to do is first install Kubernetes on it and then run that command, and your node will automatically get joined with your Kubernetes master. Right? So this is how Kubernetes actually works from the outside. Now let's understand how it works from the inside by understanding its architecture. Alright guys, so the first thing in Kubernetes that you will deploy is a pod, right? A pod is nothing but a container. But the difference is a pod can have multiple containers as well, right? And that is the case when say your application is deployed in a container, but it also needs say a separate container to run along with it, right? For example, if you have a PHP container and your files are in a different container, then basically these two containers cannot work without each other, right? Your files needs the PHP container, and your PHP container needs the files to basically give you the website. So these two containers are bound together. They are supposed to work together. And for those very reasons, we have pods. So usually pods have a single container, but like I said, there could be a situation where you have a container which cannot exist without the another container. And in those cases, you deploy multiple containers inside a pod, right? But for the sake of simplicity, you can understand that a pod is nothing but a container, right? So this is one single pod, this is a second pod, and this is a third pod. So basically, we are deploying three containers of the same application, right? For example, I want to deploy a website on Kubernetes, right? Let's assume that. Now, when I'm deploying the website, I have an option of specifying how many replicas of my website do I want to run on the cluster. So that if one container goes down, my application doesn't go down, my traffic is automatically redirected to the second container or the third container, right? So for those reasons, you basically specify the number of replicas that you want for your application, right? So this is the simplest entity in Kubernetes, that is a pod. So you deploy a pod, or you deploy a number of pods by specifying it in the deployment, right? You can deploy a pod or you can deploy a deployment. Now, what is a deployment? A deployment basically takes care of the number of pods which are running inside Kubernetes, right? So what you do is basically you create a deployment which automatically creates pods for you. But while you're creating the deployment, you specify which image in the container do you want to run and how many instances of your container you want to run, right? That is, I'll specify the number of replicas and I'll also specify the image of the container in the deployment, and my deployment will automatically take care that my number of containers are running on the number of I specified while creating the deployment. Also, the image that I've specified is present inside each pod, right? So this is what a deployment is. So to summarize, a deployment basically deploys the number of pods that you want and the kind of image that you want in that pod. Okay, so this is a deployment. Now, if a user, our understanding that we want to gauge from this particular slide is how a user or how a person like me who is using our application will be able to access the application which exists inside your pod, right? For example, if you go to Intellipaat.com, how will Kubernetes serve your website to you, given that the Intellipaat website itself is inside a Kubernetes cluster, right? So as a user, you basically will be going to a URL, and that URL will be pointing to the server, which will basically have your application. So in this case, the deployment exists on any node on the cluster, and therefore you would not know which node do you have to contact on. So in Kubernetes, what happens is any application that you deploy can basically be accessed through any of the IP addresses that is there on the cluster. For example, if there are 4 servers, 1 master and 3 nodes, any of the IP addresses of the master or of the nodes would give your way or give you access to the application, right? So in your now, for example, if I go to Intellipaat.com, Intellipaat.com can point to any of these IP addresses. That is my choice, what I want my domain to point on, right? That is my choice. But irrespective of the fact, any IP addresses that I go on, I'll be able to access my deployment. But I cannot access my deployment directly. What I have to do is I have to have a service that I'll be accessing. Now, what is a service? A service is basically an internal load balancer for all the pods which are running. Now, the problem statement was, if there are 3 pods which are running inside my cluster and which basically are hosting the same application, how would the user know, or how would the cluster know where exactly should this user end on, right? Should his request be routed to pod 1 or pod 2 or pod 3? Because all of these have the same application. So my user doesn't care which pod is serving his request, but how does the cluster handle this request? For this reason, in front of every deployment, you have a service. And service does nothing but exposing the deployment to the outside world, right? So this service automatically load balances the requests coming to it randomly, right? So not randomly, basically if you are sending a request for the first time, if yours is a first request that the service is receiving, it'll probably send your request randomly to any pod. But as and when more and more requests comes in which are concurrent in nature, right, then service decides whichever pod is more free will get more requests, right? So basically service is nothing but an internal load balancer which will be catering to your request. So the moment you send you want to go to Intellipaat.com, it will basically point to an IP address, and that IP address would point to the service which will basically internally load balance your request to any of these pods which are available over here. Okay, now the question is that, say I want to go to Intellipaat.com/blog, right? And when I want to go to Intellipaat.com, how would it differentiate where exactly my application is, right? So for example, if I type in Intellipaat.com/blog, it should basically go to the blog page, right? If I go to Intellipaat.com, it should basically come over here. And there comes the problem of having multiple services. So say this is my blog service and this is my website, my homepage, right? Now, how will a user know that which service to go on? Obviously, for a user, the only way he can interact is a URL, right? So say he goes to Intellipaat.com/blog. Now, how will the cluster know where exactly to send his request, right? For that, we have something called as an ingress. So what an ingress does is, based on the request which the ingress is getting from the user. For example, if the ingress says that this user is requesting for Intellipaat.com/blog, so what the ingress will do, it will basically send the request to this service. If it sees that the user is requesting Intellipaat.com, it will send the user to this service, right? And basically this has the blog application in it, and this has the homepage application in it, right? And this is how basically internally your Kubernetes works. So your user would send a request which would go to an ingress, and the ingress will decide based on the path that the user is requesting which service to send the request to, right? Your cluster can also not have ingress. In those cases, you might not have multiple exposed services on your cluster, right? In those cases, you will not be requiring ingress. But in cases when you have multiple exposed services on your cluster, in that case, you always have to use an ingress, right? So basically, this is a summary of how Kubernetes works internally. Now let's go ahead and do some hands-on to see how actually we can implement what we just learned. Alright, so before starting the session, I would just like to tell you guys, if you guys have a cluster on Minikube, if you have a cluster on Google Cloud, AWS, anywhere if you have a cluster, all the commands that we're gonna run right now are gonna run the same, right? Most of you guys must be working on Minikube. What I'll be doing is I am basically working on an installation on AWS, right? So I'm not going to discuss how do we set up the Kubernetes cluster in this session. Probably I'll add a new session for that, where I'll discuss different ways you can set up a Kubernetes cluster. In this, I've already set up a cluster. So let me just quickly go to the terminal to start with our hands-on. All right, so our terminal is here. Now over here the cluster is up and running. Now the way you can see that the cluster is up and running is by checking the number of nodes that are joined on the cluster, right? So for that, if I type in kubectl, which is basically kube control, so the kubectl is the command with which you control the whole Kubernetes cluster. So the first thing that I want to see is the number of nodes which are running on my system, right? So the number of nodes running on my cluster are kubectl get nodes, and these are the two clusters which are, sorry, two systems which are there in my cluster. This is basically my master. So all my applications will be deployed on this. That is my worker node, right? And both of them are in the ready state, right? Now you can also see what all pods are running on your system. To see all the pods which are running on your system, all you have to do is type in kubectl get pods and then hyphen hyphen all namespaces. This will basically show you all the pods which are running throughout your cluster, right? And if you want to see where exactly your pod is running, so all you can do is just go again here and type in -o wide, right? So here are all the pods which are running on your cluster, and some of them are running on one node, some of them are running on the other node. Your master is basically 172.31.44.86. So all the 86 IP addresses that you see here are running on the master. So this pod is running on the master and this pod is running on the worker, right? Then you have IP addresses like this, wherein you have 192.168.1.2. All these IP addresses are basically the IP addresses of the container. So like I told you guys, Kubernetes works off their own network, right? So if one container on or one pod of your cluster wants to interact with another pod, they can interact through these IP addresses. But these IP addresses are only valid inside the Kubernetes cluster, right? They are not valid outside. So if you type this IP address in your browser, you will not get anything. So let us try that. So if I go to my browser and I type in Control V, you'll not be able to see anything. Reason being that this is a private IP address, right? This is only visible to the cluster which is basically working over here, right? Now the first thing that we want to do is basically deploy pods. Now we have to create a deployment. Now in order to create a deployment, you have to write a YAML file. Now what is a YAML file? A YAML file is basically a file in which you specify all the specifications of your deployment. For example, I want a deployment which goes by the name of Nginx, right? The specification of this deployment would be that I want 3 replicas which should be running, right? And the containers should have the image Nginx 1.7.9 running on it, and the container should expose the port 80, right? Now this is the deployment that I want to run. Now say I want to change the number of replicas to say 5, right? So I'll specify 5 over here. I'll save and exit this file, that is deploy.yaml. And now in order to create a deployment, all I have to do is kubectl create deployment and then specify this file, which is deploy.yaml. Hit enter, and now it should create a deployment for me. The reason it didn't create the deployment for me was this. All right, so kubectl create and then you specify -f space and then deploy.yaml. Now this should correct the error. So let me first clear the screen. So clearing the scene, and now in order to create the deployment, there are two ways of doing it. Either you can specify create deployment and then the name of the deployment, that is Nginx say 1, and then the image of the deployment, which is Nginx colon 1.7.9. So if I do this, it will create a deployment called Nginx 1. So like you see, it has created, and now what you can do is you can basically see the pods which are running for your Nginx. So since you didn't specify any number of replicas, there's only one pod which is running for this particular resource, right? And it's nginx1. Now let us see how we can create it from a file, that is deploy.yaml. In order to create a deployment from a file, all you have to do is kubectl create and then -f and then specify your file name, which is deploy.yaml. Now if I hit enter, all you have to do is see kubectl get pods, and you can see that there are 4 replicas of nginx running over here, right? It's not 4, it's actually 5 replicas of nginx running over here, right? And now if I go to my deploy.yaml, I can actually see how much of replicas I've specified. So I specified 5 replicas, and hence I have 5 replicas of nginx running over here, right? So these are all pods, and like we discussed in the architecture, so let me quickly go to the architecture. So here is the deployment, and it has the number of pods specified inside it, right? And this is what exactly what we have done. We have created a deployment, we specified the number of replicas, and these are the pods being run for that deployment, right? And all you have to do for deleting all the pods, all you have to do is delete the deployment, and it will delete all the pods which are running inside it, right? For example, I created the nginx1 deployment, so all I have to do is kubectl delete deployment and then specify the name, which is nginx1, right? Hit enter, and now nginx1 has been deleted. So if I do a kubectl get pods, I can see that there is no nginx1 pod running right now. There's only nginx deployments pod which are running, right? So we have deployed a deployment which has number of pods which are running inside it. Now in order to access these pods, now what is running inside these pods? So if you want to see, like I said, where exactly your pods are running, all you have to do is kubectl get. So let me first clear the screen. So kubectl get pods -o wide if you want to see where your pods are exactly running, and your pods are all running on the node, right? So this is the IP address of your master, which is 172.31.44.86, and all your pods are running basically on the client, that is on the worker node, which have the address 172.31.38.140, right? Now you can check if these pods are running as containers on your worker by going over here. This is my worker, right? So if I specify, say, docker ps, I can see that these are all the containers which are running right now, and all these containers are basically the containers which are running inside this pod with the system containers which are running for Kubernetes, right? So my pods are now running on my worker. The next thing that I want to do is being able to access these pods. So if I go to these IP addresses, I'll be able to access these specific pods, right? But only inside the cluster. For example, if I type it in the browser, I'll not be able to see anything. Let's try that. So if I go to my browser and I type this IP address, obviously I can't see anything, right? But if I type the same IP address over here, I'd be able to get what is there inside the pod, which is basically my nginx file, right? So I am able to access the pods on the cluster. Now I want to access it outside. Now for that, what we discussed in our diagram was we need a service. We need a service in order for us to basically interact with the pods. Now let's create a service. Now for creating a service, all you have to do is type in kubectl create service and the type of the service. Now there are 3 or 4 types of services that you can deploy. Right now we have to deploy a service called nodeport. Okay, what all different type of services are there? We're going to discuss this in our coming sessions. Right now, let's just focus on creating a service which is of type nodeport, right? Once you specify the type nodeport, the next thing that you have to do is specify the name of the service. And remember guys, the name of the service should always be the same as that of your deployment, right? So for our case, our deployment's name was nginx. We'll specify that. And now let's go ahead and specify the ports where your service should basically point on, right? So the 80 port of your service should basically point on 80 port of your pods, because when you created a deployment, you specify that 80 port of the pod should be exposed, right? So you specify 80 colon 80. Why 80? Because Nginx works on port 80, right? You specify this, you hit enter, and now your service has been created, right? So to see your service, all you have to do is kubectl get service, you enter, and now you can see that a service has been created, which is of the type node port and is available on this particular port. Okay, so node port basically means that a port will be opened on the master and on basically on the cluster, and using this port you can access your pods, right? So if I copy this port, and now basically what I want to do is go to my master's IP address, which is this, and then open a new tab. Now specify the port, which is 31827 31827. I specify this, and now all I have to do is hit enter. So the moment I hit enter, I can now see my Nginx image, which basically means my service is working correctly. It is basically pointing to my pods. Basically my request is being load balanced among all the pods which are running. So there are basically 5 pods which are running. So my request is being load balanced among these 5 pods. Okay, so now let us check if it's actually the service which is load balancing it. So let us try deleting the service. So kubectl delete service, and then specify the service name, which is Nginx. Hit enter, and now if I go over here and try to enter, I will not be able to access it. So let me just copy this once more and open it in a new tab. So as you can see, now I'm not able to access my cluster, right? So for the first 2 minutes, it was basically accessing my website from the cache, right? What I did was I opened an incognito window, and when I entered the IP address now, it is not able to access the website, right? Similarly, if I do a refresh here, it is still able to access because it is accessing this from the cache of this system, right? That's why it is able to access. But in an incognito window, you can clearly see it is not able to access this service. Okay, now again if I create a service, it will be able to access. So kubectl create service, which is Nginx, and the type of the service is node port, right? And I want this service to be available on port 80, so I specify that. Okay, so it has been created, and if I do a kubectl get service now, I can see that this is the port it is available on. I copy this port number, I paste it over here, and I'm able to access the Nginx service. So it is that simple, guys. Also, like I told you guys that this port is also available throughout the cluster, right? It's not just on the master. So if I copy the node's IP address, which is this, and come back here and basically just change the IP address to the node's IP address, you can still access the service, right? As you can see, you can still access the service. Reason being, this port is available throughout the cluster. Any IP address that is of the master or the node I specify with this port, I'll be able to access the Nginx service. Alright, so guys, this was the hands-on that we had to do today. Alright guys, so with this, we come to an end to our session. So thank you guys for attending today's session. I hope you guys learned something new today. Now, all the commands that I just showed you today, I would recommend you try it on your own. You try to probably change the deployment file, so you can see the deployment file by going to that part of the video and just copy it from there, right? Try changing the name of the image and try running that YAML file, and you'll be able to basically deploy your own application with a custom service and be able to access it from your browser, right? And that is the whole point, right? So thank you guys for attending today's session. Have a great day ahead, and goodbye.